Hi, and welcome to the second of two videos for section 2.6. This is a pretty important video, pretty important part of this section, because we're going to be looking at the composition of functions. So you're going to have this on your in-class exams, you're going to have this on your final exam, you're going to have it in calculus if you go on to calculus. I'm trying to think if you have it in 127, can't recall off the top of my head, but it's an important concept, this composition of functions. So let's look at a definition first. So given two functions, f and g, the composite function and we write this f with a little open circle g. This we say is f of g. So when we see this notation, f with a little circle g, this is f of g, which means it's the composite function. So the composite function, f of g, is defined by f of g of x is, as it sounds, f of g of x. So we take the g function, we plug it into the f function and simplify it. Or if we are given a number to evaluate, we can plug that number into the g function, then take that number and plug it into the f function. Either way. And the domain, this is ultra important here. So the domain for f of g is the domain of g intersect with the domain of f of g. So if I have to find the domain of a composite function, first I need to find the composite function, determine what that domain would be, and then intersect it with the domain of g. So it's the final function plus the function g itself. That's what I'm trying to find the intersection of. So let's look at an example. So let f of x equal x squared, and g of x is equal to x minus 3. First thing I want to do is find f of g, and the order we can change. Find g of f. So that means what? That would be g of f of x. And so the domain would be what? It would be the domain of the composite function with the domain of g. So whatever function is going inside, that's the domain we're worried about. So find these two and their domains. And two, we want to find f So f of g of 5, and find g of f of 7. So I'm going to erase this here so we have a little room to work. So first, let's find the composite function f of g. So that means what? That means we take the function g and we plug it into f. So it's f of whatever g is, x minus 3. So just if I want to find f of 2, I plug in 2 everywhere I have an x. Well, now I have f of x minus 3, so I plug in x minus 3 anywhere that I have an x. So that's it, just x minus 3 squared. That's my composite function, f of g of x. What's the domain? Well, what's the domain for these two? Well, the domain for f of x is all real numbers. Domain for g is also all real numbers. I don't have a denominator. I don't have a radical. So therefore, all real numbers are going to work. How about this one? First, I need the composite function. What's its domain? Well, same thing. Because I don't have a radical, I don't have a denominator, this domain is also all real numbers. So the intersection of g of x with f of g of x, their domains is what? The real numbers intersected with the real numbers. So the domain for this would just be all real numbers. How about g of f? Well, now I'm taking f, which is x squared, and plugging that into g. So I want g of x squared. So I plug in x squared anywhere I have an x, which is here. So I get what? I get x squared minus 3. So you can see these are a little bit different. And again, this is all real numbers. So because I'm doing g of f, I'm worried about the domain of f. F is also all real numbers. So because these are all real numbers, the domain for this one would be all real numbers. Now, we want f of g of 5. So we found what the composite was. It's simplified nicely for it. We just put it in. So we can do what? We can now plug in 5 into the composite function, so we get what? So f of g of 5 is 5 minus 3, square that, so that's 2 squared, which is 4. But what if it didn't simplify nicely? What if f was an ugly function and g was an ugly function, and I couldn't simplify it to this? Well, what can I do? F of g of 5 is the same thing as saying f of g of 5. So first, let me figure out g of 5. And g of 5 is what? Well, g of 5 would be 5 minus 3, which is 2. So then I want to find f of this value, 2. So if I plug this into my f function, that's what? 2 squared, which is 4. Same value that I got, I just went 2 different routes. One was already simplified, so I plugged in my x, gave me a value. The other, I figured out g of 5, plugged that number into f, and then simplified, and I was done. You're going to get the result the same way. So try g of f of 7, and try it both ways. Try it using our composite function, try it by finding f of 7, and whatever number that ends up being, plug that into the g function. So you want to hit pause, that's fine, come on back, check your answers. Welcome back. So if we use our simplified version, we had what? G of f of 7 would be 7 squared minus 3, which is 49, minus 3 is 46. But what if instead I figured it as g of f of 7? Well, this would be g of what value? Well, f of 7 is, plug that in there, 7 squared is 49. So I want g of 49. So plug that into my g function, that's 49 minus 3, which again gives me 46, the same value, so I know that I can be pretty sure that it's right, and there was 2 ways to go about doing it if the function didn't simplify nicely. All right, let's look at one more example, and that'll wrap up the videos for section 2.6. So it's a little more complicated functions than we had here, but I would recommend once I get the problem written out, go ahead and hit pause, try to solve it if you can, see if you've sort of picked up, I know it's a brand new topic to you, but picked up enough of the information you can sort of work through this. So we want to let f of x equal the square root of x, and g of x is the square root of 2 minus x. We want to find the following. So first, find f of g. And second, find g of f. And for both of these, find the domain of each composite function. So again, go ahead and hit pause here in a second. I'll give you a couple hints. We want to do what? We want to find the domain of f. We want to find the domain of g. Then find the composite functions, and you'll need to find the intersection of those domains accordingly. So again, go ahead and hit pause. Try to work both of these if you can. If you can't, then that's fine. Keep watching along. We're going to start up here in a second. If you do get an answer, come on back, follow it through, see if you ended up with the same answer. All right, welcome back. If you hit pause and you tried it, let's deal with number 1 first. Well, actually, first, let's figure out each of these different domains. For this one, the value underneath has to be greater than or equal to 0, right? So that means x has to be greater than or equal to 0, because it's a radical. Same thing here, this guy has to be greater than or equal to 0. So if I add x to both sides, that means what? X is less than or equal to 2. So if I flip it so it looks right, x is less than or equal to 2. All right, so now those are the individual domains for each function. Let's find our composite function. So we want f of g. So that means f of g of x, which is 2 minus x. So if I plug this in, anywhere I have an x, it gives me what? The square root of the square root of 2 minus x. I just took this radical, plugged it in for x, so I still have the square root on the outside. So I can simplify this using my radical rules, right? If I have square root of a square root, that's what? That's just the 4th root of 2 minus x. So the domain for this is what? So we're worried about just this one alone. Well, because it's an even root, it's the same one that we got here. 2, 4, 6, 8, 10, whatever it is, if it's an even root, we're going to have this. X is less than or equal to 2. We're also concerned because it was f of g, is what's the domain of g? So it's the intersect of that plus the composite function. Well, because they're the same, the domain for this composite function is just this guy here, x is less than or equal to 2. And if you want it in interval notation, whoops, let me get a bracket because we can have it. Have the 2. So in interval notation, the domain for this would be negative infinity up to 2. And the composite function is the 4th root of 2 minus x. So now, let's try number 2. So we have what? We want g of f, which is g of the square root of x. So I plug that into anywhere I have an x. So I get what? I get square root of 2 minus the square root of x. So this one doesn't simplify as nicely as the other. That's it in terms of what's the composite function. But we still need the domain. And then we're also concerned, because it was g of f, it's the intersection of f, which is x has to be greater than or equal to 0, with this composite function. So in order for this guy to find the domain of that composite function, we know what? We know that this piece has to be greater than or equal to 0. So 2 minus the square root of x has to be greater than or equal to 0. So if I add the square root of x to both sides, I get what? 2 is greater than or equal to square root of x. I'm going to flip-flop them, so because I flip-flop it, I have to change the sign as well. So that means the square root of x is less than or equal to 2. So to get x by itself, what? I have to square both sides. That means x is less than or equal to 4. So now, this is the domain for the composite function. So this is the domain of square root of 2 minus square root of x, but don't forget I have to have it intersect with the domain of f. And f, the domain of f is x is greater than or equal to 0. So the intersect of these is what? F is 0, it includes it, goes up to infinity. This one is 4, includes it, but goes to negative infinity. So the intersect is what? The intersect is from 0 up to 4. Or if we want to put it in interval notation, 0 up to 4. So that's it. That one a little more difficult. Same idea though as number 1. We need the domain of that function itself intersect, because we can't just say everything can be less than 4, because why? We're going to run into the trouble of the f function that had to be bigger than 0, so I couldn't say x is less than or x is equal to negative 10, because that would cause an issue here. So the domain 0 to 4 includes it both. That wraps up the video number 2, which wraps up the video for section 2.6.